Hello, my name is Zen Lee, and this is my video on Millikan's oil drop experiment. Now, a little background information on Robert Andrews Millikan. He was born on March 22nd, 1868 in Morrison, Illinois. And after that, he went on to get his doctorates in physics in Columbia University in 1894. Now on to the reason for this video. In 1909, he devised an experiment in which he tried to figure out the charge E of an electron. With this work and his later work that he would go on to do for the photoelectric effect, he was honored with the Nobel Prize for Physics in 1923. Now for his experiment, this was the apparatus that they designed. First of all, you would have an atomizer here towards the top filled with oil that would mist droplets of oil in the apparatus. As the droplets of oil fall due to gravity, it comes across these two charged metal plates, one on top and one on the bottom. As the oil droplets fall, these oil droplets are then hit with an X-ray, which then negatively charges them with electrons. In this chamber, there's also light sources here, which illuminate the drops of oil, so it could be better viewed through this viewing microscope. These two plates here are charged and regulated through voltage outside of the system. Now, the experiment that follows is when the oil drops through these plates, through this opening in the top plate, the droplets of oil slowly fall due to the force of gravity. These plates are then charged up and have a certain effect on this charged drop of oil. If Millikan added more voltage to the system, the drop of oil would rise and would go up more towards the top. If a lower amount of voltage is applied, the droplet of oil would tend to drop downwards due to the force of gravity. Through this eyepiece that Millikan devised and source of light, Millikan was able to get these oil drops sort of floating midway, not really falling, not really going up, just sort of in an equilibrium state. In this animation, the atomizer spritzes mist and droplets of oil inside the chamber, which then slowly descends due to various forces like gravitational force, electrostatic force, and viscous drag force. These drops are then observed by scientists through an eyepiece. X-rays are then used to ionize the air, which when in contact with the oil drops, gives them a negative charge. This charge allows the droplets of oil to be affected by the voltage given to these plates, which then affect the rate that they fall. When he got these drops to a sort of equilibrium state, he had to work on this equation right here. Since the force that was acting on the oil drop that was causing it to fall was gravity on one side, and the other forces were electricity that were keeping the droplets of oil up. All he had to do was solve for this equation in order to find the charge of the drops of oil. Since Millikan already had the mass of each drop of oil and he could regulate the voltage on both the plates. All he had to do was solve for the charge of a drop of oil. Now, how did this work? When measuring for the charge of an electron of the drops of oil, Millikan found the results of the charges of the drops of oil to be numbers that were in multiples of around 160 zeptocoulombs. He realized that all the drops of oils that he had experimented on all had a similar number where it was multiples of this 160 zeptocoulombs. So this must mean that each electron should have the charge of 160 zeptocoulombs. If there's 2 electrons, it would be 320, and so on and so on. So with this and the weight of the drops of oil and the voltage applied to the system, Millikan figured out that the charge of 1 electron was 160 zeptocoulombs, or the number we know today, 1.60 times 10 to the negative 19 coulombs. Millikan's experiment wasn't free of scrutiny or perfect, however. After he published his research, the public went back to look at his private laboratory notebooks and saw that around a third of all the drops he had measured were used. So 2/3 of the information that he gathered were not used and omitted from his article. This led to accusations of Millikan throwing out numbers that were slightly off from the numbers he reported, which led to Millikan's work being scrutinized as being invalid. However, while there were many discarded sets of data, Millikan came out and claimed that he took the experimental data for his paper in a 9-week span, and in those 9 weeks, he measured about 100 drops. In those 100 drops, 25 sets of data were aborted due to faults in the procedure, and of the remaining 75, he used 58 data sets that were nice enough for his numbers. Although this experiment seems very simple fundamentally, small experimental errors can cause erratic results, as can be shown in Millikan's predicament, where all his numbers weren't perfectly accurate. So in conclusion, the Millikan oil drop experiment is a simple, easy, and early concept to learn and understand to solve for the charge of an electron. The importance of this experiment back in the day was that it demonstrated that charge can actually be quantized. Today, this experiment of Millikan's oil drop experiment is repeated by multiple generations of physics students in order to help them understand conceptually more about physics in a simple and easy to learn packaged experiment. Thank you.